Hey, favorite 7th graders. Today I want to teach you how to simplify expressions where multiple exponent rules need to be followed. So please make that the title on the next free page in your math notebook. And when you've done that, this is a lot. So close it up and give me a super brain today. We have learned a lot of very exponent type rules. We have talked about negative exponents. 6 to the power of negative 3 is the same as 1 over 6 to the power of positive 3. 6 to the power of positive 3 is 81, so it's like 1 over 81. This one, 2 to the 4th to the 5th, we worked out, where we would do this 5 times before and simplify it down to just having one exponent. And some of you notice there's like a little trick. This ends up being 20 of these when you write them all out. 4 times 5 is also 20, so you may have noticed that. That's one exponent kind of rule we learned. 2 to the 4th times 2 to the 5th. Here we expand it out for 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2, and that ended up being 2 to the 9th, and there was like a little bit of a trick there. And then here, we kind of did this one like this. This was the harder one to remember. This would be 4 2's in the numerator, 5 2's in the denominator. Each of these made a 1. And so that's like 1 times 1 times 1 times 1. And then there's a 2 left in the denominator. And so that would have ended up being 1/2, like 1 over 2 times 1 over 1. So which was the same as, there was a trick there too, 4 and 5, that was the same as 2 to the power of negative 1. So we've noticed all of that in the past. So let's look at some questions like this where there's like, okay, now I've got to like kind of combine all of those things. So most of these, there's like a long way to do it and a short way to do it. Depends on if you know those little tricks that happen here. I don't like to refer to the tricks, but I know you guys notice them a lot and how they work. So you're welcome to apply them. It will speed you up, but it's not totally necessary. Here what you're seeing is this 2 means whatever is in there, I have 2 times, right? So that's like saying we have 8 to the 3rd power times 8 to the 4th power twice times itself. So it would be that times that again, right? First time, second time. And that's 3/8, and that's 4/8, and that's 3/8, and that's 4/8. And altogether, what is that about? 14/8. So you can always just expand out and figure out your way through. The other way you can kind of do that is some of you are starting to notice these patterns and saying, okay, if I remember what trick goes with which one, I would remember that this is 8 to the 7th power to the 2nd power. And that trick I know too is 8 to the 14th power. So that's okay if you're comfortable with those tricks, but I want you to know you don't have to be. You can always just use your common sense, figure out your way through. Same thing here. This is 8 to the 6th over 8 to the 2nd to the 3rd. So what that effectively ends up being is I have this that many times. Right? Which is going to be like all these 8's in the numerator, 6, 12, 18 8's in the numerator. I'm just going to do dot, dot, dot. And then only, well, let's do this. I'll put 6. And then there's going to be 6 8's in the denominator. And let's say I did 6 of them here. How many were there going to be altogether? 6, 12, 18. So there's like 12 more. I'm just going to write it like that. All of these would make my 1's here. So this would all be like a big 1. And then there'd be 12 more 8's in the numerator. So that's going to end up being 8 to the 12th power left times 1 times 1 times 1 times 1. So again, if you're good at your little tricks, you say, well, I know how this trick works. That's 8 to the 4th power to the 3rd power. I know how that trick works. That's 8 to the 12th power. So you can do these with a lot less work, but I don't want you to ever feel like you have to memorize all these tricks. So that's if they all have the same base. What if they have a different base? Like here, it's 8 times 5. rather than 8 times 8. And here it's 8 divided by 5. So let's think about that. We haven't really seen ones like that. So this means I have second power. That means I have 8 to the third power times 5 to the fourth power twice times itself times that again. Right? Now I can't really do anything special with these. This is 8 times 8 times 8. This is 5 times 5 times 5 times 5. Those aren't going to end up going together. There's no way to make that into some seventh power thing because they're not the same base. So I can't really leave those together. What I can do is some rearranging. I do have these, which will make 8 to the sixth power if I kind of rearrange. Remember, multiplying order doesn't matter. So this times this times this times this, I can shuffle them around. When you multiply or you add. And then these will make that, and I can leave it like that. That's considered simplified. There's no way to combine the two bases, but you can rearrange and combine the two that can go together. The 8s can go together and the 5s can go together. Same thing here. You know, when I make my numerator and denominator here, that's 8 times 8 times 8 times 8 times 8 times 8, and that's 5 times 5. Those do not make 1. So there's not really very much I can do with that. I can't like cancel or make 1, anything like that. So that doesn't really work. So what I do know is if I do this 3 times, I have that 3 times, that's 8 to the 6th over 5 to the 2nd, times 8 to the 6th over 5 to the 2nd, times 8 to the 6th over 5 to the 2nd, multiply all my numerators, 6 eighths, 6 eighths, 6 eighths, that's 8 to the power of 18. 2 5s, 2 5s, 2 5s, that's 5 to the power of 6. And that's it. That's as far as you can go. There's no fancy thing you can do with these different bases. We would just say that that's simplified enough. Okay. One more situation that's new is what if you have a negative exponent in an expression like this with this business? So if we do that, we've got to remember what that negative exponent means. That means it actually ends up being in the denominator, like this, right? Times 3 to the 7th, all squared. So if I imagine this is a fraction, I can combine those into one fraction. I can combine that into 3 to the power of 7 over 3 to the power of 4, all still squared. Now, again, if you remember how this one would work, I would do all my numerator ones and then my 4 denominator ones. Those would all make 1s, and there'd be 3 left. So this inside, I can kind of condense down to 3 to the third power, still to the second power. And this was the one where those are going to end up multiplying. That's 3 to the third times 3 to the third, which is 3 to the sixth. So they take some work and some understanding, but as long as you're kind of patient and just do the thing, works fine. Now, again, also, if you're used to your tricks, you know, those end up being that. That's the one where you add the two exponents if you found the trick. And then those, that's the one where you multiply the two exponents, end up being that. So there are like massive shortcuts to this if you understand them. But again, don't feel like you have to memorize any shortcuts. All right, let's write them down. These all come from your pretest that I want to look at today. We're going to write these down. So if you have that pretest, we can write them on there. If you don't, just write them in your notebook. Let's start with these two. These were true, false. And let's combine all of this and see. So a couple ways you can do it. You can kind of do this and write that 3 times, or you can do this first and then do that 3 times. It doesn't really matter which way you do it as long as you kind of follow, you know, proper order of operations well. So this one, I think it's easiest to combine these first. That ends up being, if you want to go the long way, 6 times 6 times 5 more 6s. 1, 2, 3, 4, 5, which ends up being 6 to the 7th power. So you can either do the little trick there if you remember it, or you can write that part out and simplify what's in the parentheses to 6 to the 7th before raising it to the third power. So that one, that is 6 to the 7th 3 times, which is 7 sixes, 7 sixes, 7 sixes, which is indeed 6 to the 21st power. All sixes, so that one ends up being true. Again, here you may remember that trick, you may not. No big deal, either way. All right, let's look at this bottom one. When you're ready, unpause and we'll do that. So this one, let's see if that's true. So 5 to the power of -3, that is the same as 1 over 5 to the power of +3. That's what we do with negative exponents, times 5. And let's see if that equals that. So if I imagine that 5 by itself to be a fraction, then I end up with 5 out of 5 to the third power is 5 times 5 times 5. Those make a 1. And there's nothing in my numerator left except 1. I guess 5 times 1 is 5. And that leaves you with 1 over 2 5s in the bottom. And that is indeed true as well. The other way to do that is if you remember this, you don't have to write an exponent of 1 when it's just a 5, but you can. Those would combine to, if you know that trick where you add the exponents, that would be 5 to the power of -2, which is that. So if you like the tricks better, that works. If you like expanding better, like I do, that works. So get 2 more when you're ready. Unpause and we'll go ahead. So this is an example where there's like different bases. Rather than everything having the same base, sometimes they don't. So what I want to do here is I want to use what's called the commutative property. You'll notice all of this is multiplied, times, 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 times. And if I do that, when you multiply or add, commutative property means you can rearrange things into a different order. So I'm going to put the 5s together, 5 to the 2nd times 5 to the 6th. And then I'm going to put the 3 bases together, 3 to the 4th times 3 to the -9th. And then I can look at them separately. Those are going to make 5 to the power of 8, which is good. Those are going to make 3 to the power of -5, not +5. And so that's as simplified I can get that. Or we can move that to the denominator, and you would get 5 to the power of 8 in the numerator and 3 to the power of +5 in the denominator. But either way, we definitely don't get that. Okay, last one. I have just about enough time to do it. So again, 2 different bases here and an exponent. So this is this twice, 6 to the 5th over 7 times 6 to the 5th over 7. All just common sense. I'm not doing anything fancy here. I'm just kind of writing out what I've got. Multiply my numerators. That's 5 6s times 5 6s. I end up with 6 to the power of 10 in the numerator. 7 times 7 is not 7. It's going to be my issue. It'd be 7 to the 2nd power, which is, I think, what they were trying to do with the trick here, is this part we got, forgetting that this exponent also goes with the denominator. Not quite. So that's false. This would be correct for that. And y'all, that is how you solve problems that involve multiple exponent rules, multiple exponent properties. Kind of a lot to it. They take a lot of patience and a lot of common sense. Hopefully these rules are coming together for you. If the rules aren't, hopefully the common sense part where we expand, figure out what we've got is working for you as well. This is a biggie, y'all, and they're only going to get more advanced than this from here. So if you need to give this a second go to really feel like you're going to show up to class tomorrow feeling confident and understanding, please do. And I can't wait to see you then.